All right, a quick video on the two-step stoichiometry that we've been doing in class. So you should know at this point that there is a conversion factor from grams to moles and moles to grams. There's a conversion factor from moles to liters, liters to moles, and a conversion factor from moles to particles, particles to moles. You should at this point, or you indicated that you understood the one-step stoichiometry, which is great. For the two-step stoichiometry, what you're going to do, and I'm just going to give you a sample problem here. Let's say we had 25 grams of CO2 gas, and you wanted to know how many liters that was at STP, at standard temperature and pressure. What you would want to do is start with the 25 grams of CO2, put it over 1. You're going to multiply it by the ratio that's going to be changing the grams into moles. So looking at units, we need to get rid of that grams, so we're going to put grams on the bottom and we want moles on top. That's the dimensional analysis. This grams has to cancel, so it's got to be down here. So that relationship is 1 mole per the formula mass of CO2. So you would look that up. You would have 1 carbon, 2 oxygens added up. When you do that, it adds up to 44. I happen to know that one, but you can add that up. If you stop there, and you would end up with 25 times 1 over 44 times 1, 25 divided by 44, and your answer would be in moles. But we don't want to stop at moles. We want to go to liters. So I'm going to continue this process, multiply it by another factor. Now we would be going from moles to liters. That conversion is 1 mole per 22.4 liters. And what, again, you're going to look for in the dimensional analysis is you want to get rid of the moles. So moles needs to be on the bottom down here. You want liters, and that relationship is 22.4 liters per 1 mole. If you do this out, you wind up with 25 times 1 times 22.4 over 1 times 44 times 1. And if you multiply those, multiply the denominators, and then do your division, you're going to wind up with your answer, and your answer will be in liters. Now, it's really important that you notice you started with grams. Grams was down here per mole. Then you wanted to get rid of moles, so moles was down here per liter, because that's what you wanted your answer in. A little trick with this two-step, in this second fraction, the top number will always be 1 mole per something. In the second one, it's always going to be something per 1 mole. So in a weird way, with these types of problems, this is always 1 mole, that's always 1 mole. And then what this number is and what this number is depends on the conversions you're doing. So here, because we were doing grams to moles, we were using the formula mass. From here to here, we were changing to liters, so that was the 22.4 conversion. So hopefully you can apply that to other problems. For example, if you had particles and you wanted to get to liters, you would do the number of particles given over 1 times 1 mole over 6.02 times 10 to the 23rd times 22.4 over 1, and that would give you your liters. Or if you had to go from liters to grams, you would take the liters times 1 mole over 22.4 to get moles, and then times the formula mass over 1 to get the grams. Hopefully this helps with two-step stoichiometry that we've been doing in class.